Hello and welcome to this video on how to run polynomial regression here in R. So let's go ahead and generate some data for the model. So we'll be using the seed 1 to 3 for reproducibility, and we'll be generating sample data which will range from -10 to 10 with a standard deviation of 5. Let's go ahead and run this chunk. Here we have our sample data with x and our dependent variable y. For the first polynomial regression model, we'll be using poly for orthogonal polynomials. This means that the dot product of the independent variables is equal to 0. This is good if you know that your model has multicollinearity. Let's go ahead and run this model. So the coefficients of the model are actually not interpretable. However, we can see that the adjusted R squared is 0.94, which is extremely high. This indicates that the model is effective at explaining the variation in y. Now let's go ahead and run the second polynomial regression model, which uses manual polynomial terms. So we have x and x squared. Here, the coefficients are actually interpretable. So a unit increase in x will lead to 2.06 points of increase in y, while a unit increase in x squared will lead to a negative 0.48 point of change. Again, the adjusted R squared is 0.94, which is extremely high, and it indicates that the model is highly effective at explaining the variation in y. We can also plot the results using ggplot2. Here we see the polynomial regression line, which is a quadratic curve. Now let's go ahead and look at some diagnostic plots to see if the assumptions of linear regression are upheld by the model. So let's go ahead and look at residuals versus fitted, which shows that there aren't any patterns within the residuals that might be affecting the model. The QQ plot indicates that the data are normal as the data points fall across the line. The scale location plot indicates that the residuals are evenly scattered across the fitted values. This indicates that the residuals are constant in terms of their variance, which allows for the assumption of homoscedasticity. Finally, the residual versus leverage plot shows whether any outliers might be having an effect on the model. So here we see none of the data points having a significant impact on the model, as none of them pass the Cook's distance line. And that's how we run a polynomial regression model here in R.